Okay, so today we're going to talk about tangents to circles. Okay, we've already talked about what a tangent line is. We know that a tangent line touches the circle how many times? Once. Okay, so if we're looking at this picture, this would be my tangent line because it touches the circle only once. Now, the theorem that you want to know is that if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. What that means, yes, is that it forms a 90-degree angle. Very good. So there would be a 90-degree angle here, 90-degree angle here. Okay, and so every time we see, you'll see when we do our examples that we have a right triangle. That means we want to draw the 90-degree angle. And then what do we know about all angles in a triangle? They add to 180. So we're going to use those two things to solve for the angle measure. So let's look at number 1. In number 1, my tangent line is this line right here because it's where it touches once. So where would my 90-degree angle be? Right here. So how could I find this missing angle when I know this piece is 62 and this piece is 90? Okay, 90 plus 62 gives me 152. Then I can subtract that from 180, and that gives me that x is 28 degrees. Okay, let's look at number 2. Where is the tangent line in number 2? The bottom. It's the bottom piece. And so that means that my right angle is at the bottom. So now I know 2 of the angles, so I'm going to add those 2 angles, 90 plus 44, which gives me 134. And then I can subtract that from 180. And that gives us 46. So x equals 46. Okay, are we good with those? Okay. Now, the next theorem that I want to talk about is that if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. Basically, what that says is that the tangent line, where the tangent line and the radius meet, is where it's perpendicular. So this is my radius. This is my tangent line. And where those two intersect at this point is where it forms a 90-degree angle. And since it makes a right triangle, that means that a squared plus b squared equals c squared is going to apply anytime there's a right triangle. Okay, so let's look at some examples of that. Okay, in number 4, does it matter which one's A and B here? It doesn't necessarily matter which one's A and B, but which one actually matters? C, okay? So C is always across from my 90-degree angle. Where would my 90-degree angle be in this figure? Okay, where 8, the radius, and x intersect, so right here. So that means that 17 is my C, and then it doesn't matter which one is A or B here. So we're going to plug into our formula. We get 8 squared plus x squared equals 17 squared. 8 squared is 64. And 17 squared is, what is it? 280. Thank you. Okay, so then from there, we isolate x squared, so we subtract 64. And that gives me that x squared equals 225. Now, to get just x, we have to take what? The square root. So if we take the square root of both, my x equals 15. Okay, let's try another one of those. So let's look at number 5. So in number 5, where would my right angle be there? Where 13, which is the radius, and x meet, so right here. So my C, or my hypotenuse, is across from that. Do we know how long the hypotenuse is? No. Okay? We have that this piece right here is 7, but we don't have this piece here. How could we figure that out? Okay, not x minus 7. It's the radius. Okay, so we know that this piece from the center of the circle to the side is the radius, right? This also goes from the center of the circle to the side, so this would be 13. So how long is this entire piece now? 20. Okay, so we're going to label, I'm going to let 13 be A, x is going to be B. So I'm going to plug in and get 13 squared plus x squared equals 20 squared. I know that 13 squared gives me 169 plus x squared equals 400. So I'm going to isolate x squared by subtracting 169. And so x squared equals 231. And then what happens when you take the square root of 231? You get a decimal. Can lengths be decimals? Yes. Okay. So we would leave it as 15.2. Okay. 6 would be the same way. 6 and 7. Now, 8 and 9 are a little bit different. So let's look at 8. In 8, again, I'm missing a piece of my hypotenuse. What would I let that piece be? X, because it's the same. So you told me that above we added these two. So if I add 8 and x, what does that give me? X plus 8 or 8 plus x. Okay? So this is going to be my C. I'm going to let x be A this time and 12 be B. So I'm going to plug in and get x squared plus 12 squared equals, now I have not been putting parentheses around what's being squared because we've only had one thing each time. On C, we actually have more than one piece, so I'm going to put that in parentheses squared. It's actually a very good practice to put everything in parentheses when you square it. So I know x squared just gives me x squared. 12 squared is 144. And what's another way to write this so we don't mess it up? Because we tend to mess it up quite often. X plus 8 times x plus 8. Because if we leave it like this, most of you would tell me it's x squared plus 64. And that's not right. You actually have to FOIL this, okay? So we're going to do first times first, which is x squared. We're going to do outer times outer, so x times 8, which is 8x. Then we're going to do inner times inner, which also gives me 8x. And then we do last, which is 8 times last, which is 8. So that's 64. Okay, immediately you see that we have x squared, right? How many of you are like, crap, we have to factor? Okay, you don't actually have to factor. Because if we have an x squared on both sides, what's going to happen when we move it? It cancels out. So these are actually going to go away. There's no factoring involved in this. So let's combine our like terms. 8x and 8x give me 16x. And let's go ahead, since 144 is on the left-hand side, let's move 64 over there since it's the number 2 and get rid of that 64. So when I subtract 64 from 144, that gives me 80. And then to get x by itself, divide by 16, and x equals 5. Very good. Okay, so would you like another example like that one? Okay. Okay, let's look at 9 then. So in 9, again, we are missing this piece right here. So since it's the radius, it's the same as this piece. So I'm going to let this be x. So how long would this whole piece right here be?
14 plus x.
Okay, you can say x plus 14 or 14 plus x, either way. Okay, does it matter? Well, x looks like the smallest side, so I'm going to let that be a and 20 be b. So I'm going to plug into my formula. I'm going to do a squared, which is x squared, plus b squared, which is 20 squared, equals c squared, so x plus 14 squared. I didn't put my 90-degree sign. We know that it's where the radius and the tangent meet, so here it was on this edge of the circle, and in this problem it was here. Okay, so x squared just stays x squared. I know 20 squared is 400. Then I've got to square this thing, so I'm going to rewrite it as x plus 14 times x plus 14. That's going to give me x squared plus 14x plus 14x, and what is 14 squared? Plus 196. Okay, again, my x squared, since I have 1 on both sides, that's going to cancel. I'm going to combine my like terms here, so 14x and 14x gives me 28x. Then I want to move this number to the left-hand side since 400 is over here, so I'm going to subtract 196. So 28x should equal 204. And then to get x by itself, I've got to get rid of this 28, so I would divide by 28. And what would my x equal there? 7.3. Let's leave it at rounding to the 10th. Okay. All right, I have one more thing to show you. So flip to the back. Okay, so what you want to know about tangent lines, if there's two tangent lines, the two segments tangent to a circle from a point outside the circle are always going to be equal. So that means that this tangent line here is going to be the same as this tangent line here. So the way that we will solve anything that has two tangent lines is we're always going to set those tangents equal to each other. So let's look at number 10. In number 10, I see that this touches the circle once, which means they're both tangent. So this should be equal to this. So we're going to set 3x plus 4 equal to 40. Then from there, all we're doing is solving for x. So we subtract 4 from both sides, and that gives us 3x equals 36. Then we divide by 3 to get x alone, and x would equal 12. Now it asked me to find the length. Do I actually have to find the length here? No. How long is both of these? 40. It's given. Okay. Let's look at 11. So in 11, again, I have two tangent lines because it only touches once, so they're equal, and I set them equal. This would be 2/3 y equals y minus 3. Now, do y'all remember what the easiest way to get that fraction out is? Not necessarily the reciprocal, but 3 would make it easier on most people. So if you multiply by what's in the denominator, which is 3, that cancels out these 3's, and that leaves me with 2y equals, what am I going to have to do with this 3? Not make it, no. Since it's being multiplied, I have to multiply it by what? I have to multiply it by every single thing. I have to distribute. So I'm multiplying 3 times y and 3 times 3. So that's going to give me 3y minus 9. Would you rather move 2y or 3y? Okay, so we're going to subtract 3y to get it on the same side. And that's going to give me negative y equals negative 9. Can I have a negative variable? No. So what would happen to both these signs? They change, and we get y equals 9. Now, if I wanted to find the length of this, I could come and plug this back in. 9 minus 3 gives me 6. So my length would be 6. Okay? Shall I do the factoring one for you? Okay, so we're good with factoring. All right, 13, 14, and 15, the other classes were like, oh, those look hard. So let's walk through one or two of those. So looking at 13, they want us to find this side here. Does anybody have a thought of how we would go about doing that? We don't know that it's the same as this side, so we can't do that. Now, we've been talking about what type of lines this whole time? Tangent. So isn't this a tangent line? Would it be the same as this tangent line? Yes. Two tangent lines that intersect a circle are going to be equal, so this would be 5. Then, if I'm looking at the bottom, this tangent line and this tangent line would also be equal. So this would be 4. So how long is this whole side? 9. Okay, and then I will do 14 as well for you, just to make sure we got this. And I actually cut off part of the information. So it tells me that the perimeter of this is 42, right? Okay, so we're using tangents again. I know that this side and this side are going to be equal. So this would be 7. Then I know this side, or this tangent line and this tangent line are going to be equal. So this would be 6. Now, the only thing that I do not have are these two up here. But I know they're the same, right? So what could I let them both be? X. So we're going to let this be x and x. And how do you find the perimeter of something? You add all the sides. So we would do x plus 7 plus x plus 6 plus, I know this whole bottom piece is 13 plus 13 equals 42. So we combine our x's, that gives us 2x, and then we combine 7, 6, and 13, and that would give me 26 equals 42. We subtract 26. And 2x equals 16. We divide by 2 to get x by itself. And x equals 8. Okay? It also asked me to find TR. So how long would TR be? It would be 14 because we do 8 plus 6, which is 14.